Today we are going to model equal groups with the area model and arrays. And we are going to start by looking at our number corner calendar and make some predictions. So what I would like for you to do is look at the calendar and take 1 minute to think about what observations you can make. We're just thinking right now. Can you see okay? Is that a no? Okay, I want you to turn and talk to your partner about some observations that you have made about this month's calendar. Go ahead.
First one goes 1 by 1. The second one goes 1 by 2. The third one goes 2 by 3. The
It actually means that there's 4 of those, so it's starting out with 4, and there's another one. There's blue, green, purple, blue, green, 6, so that would be blue, and then goes to our green.
Okay.
No.
Thank you for standing. Okay, I would like for you to turn to someone that is not your partner, but is sitting close to you, so maybe another elbow partner, and talk about what you and your first partner talked about. What observations did you guys make together? So share with a different person.
And then 2 by 3, and then blue, green, pink, blue, and then actually is 2 by 5. And third one, it goes up and then
number 9 is
the first one is
Okay, about 30 seconds.
that's gonna go into the rest of and number 3 goes up to
Okay. Okay, so we're going to start with the question, what conclusions can you draw about the pattern that you can see so far? Bounty.
That is blue, green, purple.
Okay. Callan?
that 1 goes 1 by 1, and then 1 by 2, 2 by 3, and then 3 by 4, and then the next one goes 2 by 2, 1 by 3, 2 by 4, and then 3 by 5.
Okay. So can you maybe explain your thinking a little bit more when you're saying, are you saying that it's a growing pattern? Can you explain that just a little bit more so I can understand a little bit better?
Yeah, I think it's going to be a growing pattern since like every single one had an extra row or column.
Okay. Okay. All right. How would you describe the sequence of the cards? Tia? Can you explain what you mean by adding more on?
Like, since there's one right there and on the second one they added 3 more on.
Okay. So each time they add Okay, are they adding rows or columns each time? Or both? Can we tell? Okay, so who can figure out what color the squares are? Lillian, what color are the squares?
So it's blue, green, green, purple, blue, green, green, purple. So that would be blue, that would be green, and then purple.
Okay, are all of our arrays squares?
No, they're
Can you tell me which color are squares?
which colors are square?
Pink.
Troy, you think it's blue? Can you explain your thinking to me? Why do you think blue is a square?
I saw the number 1 had 1 cube, which made a square, and then I saw number 5, and there was 4 blues, and that made a square. But the first thing I looked at was number 4, and I thought that was a square. Then I looked at it again closer, and I saw that it wasn't a square.
Can you explain your thinking? Why do you think this isn't a square?
Because not all sides are equal.
Troy, tell me what you were thinking.
I thought that why it wasn't a square was because there was 4 rows on top and 3 columns.
Okay. So you're saying it's 4 by 3, so that's how you knew it wasn't a square. Because I think someone else made that observation. I was listening, and it sounded like you guys thought this was a square. But you're right. As you look closer, it is actually 3 by 4. So we can see that number 1 and number 5 are squares, correct?
Yes.
Okay. Who can predict when the next time we are going to see a square? So when will we see another blue card with a square on it? McKenna,
On the next card.
why do you think that?
Because the pattern goes blue, green, green, purple, blue, green, green, purple. But I actually think it's pink.
Okay, I think it's pink too. I think you're right.
Probably
Okay,
the
so you think that the next card is going to be a square because the next color should be
blue.
okay. Tegan, you have another reason why you
Because since all the other blue cards are like squares, I
Mhm.
think that one should be could have been blue too.
which one?
The next card after the ninth, not the ninth day.
Okay. Callan?
I'm actually gonna say no. It might not be a square because it added 3 on the 5 from the 1, so it added 3 to a blue
Okay.
both time.
Mm-hmm.
But if you look at number 2 and number 6, it adds 1, so it could be like 1 row, 1 column.
Oh, okay. So you're thinking it could come later than 9.
Yeah.
Okay. Okay, so a couple of you have predicted that it will come the next card, and a couple of you think it might come later. Who can predict what they think the total area of the next square would be? We have this area right here is what?
Just
One.
Just 1, right? Because it's 1 by 1. 1 times 1 equals 1. Andreas, can you see over here? And then we have this card, which we agreed
2 by
this is a
2.
square, right?
Yeah.
This is 2 by 2.
It's 2
What's
times
2
4.
times 2?
2, 4.
4. So if we're looking for the next square, what can you predict the area will be? Aiden?
I noticed that every time there's another blue one, that kind of half triangle thing, it just gets bigger and it adds like 1 row. Like every time there's a new blue one, it adds to like this part of each one.
Okay. So you're saying it goes over another column? Is that what you're trying to say? Okay. Who can predict the area of our next square? Troy?
A 3 by 3 because when I was looking at 4, I took away that last column, and then I saw that it made a square.
Okay, so you think it's going to be 3 by So, Troy, here's my question. You think it's going to be 3 by 3. What would the total area be if it was 3 by 3? 9. So he thinks the total area would be 9. Raise your hand if you agree with him. Okay. Does anybody else have a prediction? So most of you agree with him. You think it's going to be 9, 3 by 3. Okay. So now that we've talked about it a little bit and you guys have talked to your partners, who would like to make a prediction, not an observation, but a prediction about our upcoming pieces in our calendar? All right, Callan, what do you think?
What I think is that the next one, every single shape would have an extra column.
Okay. All right, write that down. Make sure you write your name on there. Oh, sorry. Anybody else? Who else has a prediction? Whoops. Sorry, throwing pens at you. McKenna?
I think that every blue card is gonna be shaped like a square.
All right, good prediction. All right, anybody else have a prediction? Aaron?
And every square, the blues are gonna be even.
Okay. Prediction. Go ahead and write your name. All right, I have one more. Lillian, what do you think?
So,
I'm sorry.
so I predict that every time it's the first green, will always be flat.
What do you mean by flat?
See, like number 2, number 6 are both flat.
I get what she's saying. She's like,
They're both flat. Yeah, like flat.
wait, I don't think that's gonna happen because if it already went from both the first ones are flat and then both of them have another row of a flat one, but it's probably gonna add another row.
Is that what you mean?
No.
Like it goes
I mean,
over
like it's-
columns instead of adding
No,
a row?
it just stays there. Like, it keeps staying there.
Oh, so you're talking about these two?
Yeah. Like, and then since that one's just 2, this one's 3.
Okay. So
Maybe it's doing a pattern like this 2 added a 1, but
okay.
since it started off as 2, it might add 2 more or 1.
Okay, so can you be a little bit more specific? Because you're just talking about this one and this one. So how would you describe this card and this card in the pattern?
They stay flat.
Okay, but I understand that you're saying that they stay flat, but how would we know? Because you said every green, but you're not talking about every green. You're just talking about this green and this green.
Oh, the first greens after the blue.
Okay, there we go. Thank you. All right, Callan, you have it? Okay.
She's
using a green pen. All right. I'm gonna put that right above that square one. Okay, so now we're going to record some observations. Thank you, Erin. So we have this chart so we can organize our thoughts.
Okay.
Okay, so I need you guys to help me because my back is to the calendar and I can't really, it's hard for me to turn. So we're going to start with marker 1, which means this one right here. So I need you to help me with the height. So how many columns, how many rows does it go up? The length, which would be how many columns over. The area, what's the area?
1.
Let's try this again. What is area?
Equal product equal.
Okay, let's try again. Ready? Area.
Equal
The inside of
Okay, let's look up here, right here. Remember we talked about the product of the length
times width.
Okay, you want to try one more time? Ready? Area. The product of the length times width. Okay, so if we're talking about the area, we're talking about the length times the width, which is the total number, right? So if we have this area, what's the area of 1? 1. And then I want to know, is it a square? Yes or no?
Yes.
And then what color it is. Okay, are you ready? So we're going to start with 1. What's the height?
1.
What's the length? What's the area? Is it square?
Yes.
2? Height.
2. 1.
Height is 1. Length is
2.
Area is?
2.
Is it a square?
No.
What color is it?
Green. Misty, couldn't you put an X where the square is to show it's not a...
No, we're just gonna leave it blank.
Every green.
How about number
purple,
3?
and this one.
2.
The height is 2.
Yeah.
The length is?
3.
And the area is?
6.
Is it a square?
No.
Color?
Green.
All right, how about number 4? What's the height?
3.
And the length?
4.
And the area?
12.
Good. Is it a square?
No.
What color is it?
Pink.
All right, number 5. What's our height?
2.
The length?
2.
Whoa.
No, it's 4.
Let's look at number 5. We have the height is 2. The length is 2. The area is
4.
Here. Is it a square?
Yes.
What color is it?
Blue.
All right. Number 6.
1.
1 and length?
3.
Area?
3. Oh, wait.
Is it a square?
No.
What color is it?
Green.
Number 7. What's the height?
2.
What's the length?
4.
Okay. Area?
8.
Is it a square?
No.
What color?
Green.
All right. All right, last one. 8.
3.
3.
5.
Area?
15.
15. Is it a square?
No.
No, what color is it?
Pink.
Pink. Okay, if we look at our chart right here, do you notice some patterns now that we've recorded it? So we have our height, 1, 1, 2, 3, 2, 1, 2, 3. Is that a pattern?
Yeah.
I see a 1, 2, 3 and a 1, 2, 3, so maybe. Oh. How about our length?
No.
1, 2, 3, 4. 2, 3, 4, 5. Who has a prediction of what the next length might be?
1.
Mary?
6.
Maybe 6. Maybe
1.
1?
I think 8.
Okay.
I think it's 3.
And if we have a square here, no square, no square, no square, square, no square, no square, no square.
Square.
Oh, excuse me, square. So if it's a square, what color is it going to be?
Blue.
All right. Okay, so how much information do I need to know about my pattern to make, to understand like the whole pattern? How much information do I need to know about this to understand the entire pattern? Can we understand the entire pattern now?
No. Yeah.
We can?
No.
You guys just told me that you're not sure what would come next in our pattern for the height and the length.
You probably need all rows to know which one to be the next one.
What other information might I need to understand our pattern a little bit better? Callan?
The next
You need to know what every single part of that, like the that's in the pattern, like a way like that, like
Okay.
what the thing of the pattern is.
Okay. Do you think that after a whole week of more cards, so let's say next Wednesday, do you think we'll have a better idea what our pattern is?
I think because then we get to see more of what's going on, and that can help us with it.
Okay. All right. So as we progress throughout the month and we look at our calendar grid and our arrays, be paying attention to the height and the length and the area. I think that there's a pattern that you guys will pick up on pretty soon. You're just missing, we need a couple more cards. Okay, so this is what we're going to do. So I need you to slant and look at me. Troy, are you ready? Aaron, are you ready? If you're slanting, you're looking at me. So I need your eyes on me. Thank you. Okay, I'm going to give you the signal word, which is area, okay? And when I give you the signal word, you are going to go with your partner back to your table group and be ready to listen for instructions. Are you ready?
Yeah.
Area. Area. The product of length times width. Area. Okay. So I need you and your partner to look up at the screen. So we're going to look at a specific area or array from our calendar grid. We're going to look at day number 4. I want you and your partner to take your tiles and recreate the array that is on the calendar piece. Go ahead. Can you see it okay? I'm going to zoom in. Is that better? Go ahead and recreate this array with your partner. You don't need to do one per person, just with your partner. So you should have one array within your group. One array. So one array. Good job. Okay, I'm going to give you about 30 more seconds. Okay, so here's what I would like for you to do. Most of you have it already created. I want you to talk to your partner about the dimensions of your array, and I want you to talk to your partner about the product or area of your array. Go ahead and do that.
Across. So if I take these 3 away, it would actually be, yeah. But when we added it, it wouldn't. Because it's not equal. You're supposed to be 3 up, 3 across to make it a square. It looks like 3 up,
So I can
4
multiply
across.
So I can multiply
0. We think a lot. Yes.
Your array that you built and figure out what the dimensions are. You guys good?
One more thing. We added one more.
Alright, can you stand please and look at me? I heard some really good conversations. Some people forgot what dimensions were, so they went and looked at the CCD. Good job. Okay, so what I want to know is, can you modify your array, the one that you have created right now, with the dimensions of what? What are our dimensions?
Length and width.
Okay, so what are our dimensions of this one?
The height is
3.
and the width
Is 4.
Okay, so we have 3 by 4, or 3 times 4. What is the product or the area of that one? Everyone. 12. Can you modify this array that you've created to be a that is related to 3 times 4 equals 12? Can you modify it? Go ahead and talk to your partner and see if you can modify it. Create a related multiplication fact with this array. I want you to modify your array. So I want you to take your tiles and switch them around to be a related multiplication fact.
So it's 4 with the array.
4 equals 12.
But she wants it like an array.
Okay.
Now like an array. Like 3 here.
Yeah, 3
And
there.
4 here.
4 times 3, 4 times 3. That one's 4 times 3. 4 by 3. Other one is 3.
3 here.
Okay.
4 here. I don't know. Because it's 4 times 3.
Aquí hay 4. Aquí hay 4. 3, aquí hay 3. Aquí hay 3. Hay 4.
This is the same array that I've showed you. So can you change that to look different?
Oh, yeah.
Very good.
You're supposed to do it all together. You're not doing it.
Okay, can you slant? I thought I'd trick you, but you guys got it. So, did you take any away? Did you take any tiles away?
No.
Did you add tiles?
No.
No. All you did was switch it.
to like the taller side.
So it should have looked like this.
Yeah.
Yes, so what are our new dimensions?
4 times
4 times 3. So if we didn't add or take any away, is it the same product or area as the first?
No.
What, Lacey? Yes. So this is the same. It equals how many? 12. So 4 times 3 is 12. So those are just flip-flopped, and they're related multiplication equations. So 4 times 3 is the same as 3 times 4. Okay.
Like when it was like we noticed it on the side, but now there's 4.
Okay, I'm going to give you another challenge. I do not want you to add any more tiles. You have 12 tiles, right? All the rest of your tiles should go back in your pink little cup. You have 12 tiles. My challenge is, can you create more arrays using 12 tiles with different dimensions or different factors? So you're going to take 12 tiles and create as many arrays as you can. Now wait a minute, Slant. I don't want you to start yet because I have a couple more directions. Aiden, I'm waiting on you. Mary, I'm waiting on you. Mary, I need your eyes. Okay, so you're going to create as many arrays as you can using only 12 tiles, and each time you build an array, I want you to record it on your whiteboard. Now, you've already done 2, right? So on your whiteboard you should have what?
2.
Which ones? What should we already have on our whiteboard? 3 times 4 equals 12, and 4 times 3 equals 12. So there, you should already have 2. I want to challenge you and see if you can find more. I think you can find probably at least 4 more.
You have
Right?
all of them?
You're only using 12 tiles. Okay? So you don't need any more. So see if you can rearrange those. Yes, you have to use all 12 tiles.
Times 2.
No more, no less, just 12.
Wait, do we have to write it down like this?
No, because we have to array. We have to count. Oh no, we have one.
gonna be 3
See if we can make them.
But
We got one. We
all
got one.
12 tiles.
We got one.
All 12 tiles.
No, what should I do?
There you go.
We got 2 by 1, 2 by 6.
Should we put the
2 by 1 by 12. Where's 2 by? Where's love?
Get there.
Can we do it different way?
Equals 12. Your turn to make ideas. Alright. Okay. Half that. Half 12. This way. So you're trying to like do stuff and try to get the idea that you're trying to find in your mind. Well, I might know what you're trying to make. Like put this one over here and then make it like this.
You already have 2.
And then probably like no, but it's actually upside down, so it's different. This one was the up way. Yeah, now it's short. So 1, 2, 3, 5, 6, 12.
Okay.
We could do more.
Okay, let's talk about this real quick. You guys were on the right track with the 1 times 12, but 7 times 6 equals 12 is not right because this, as an
We
array,
had an L.
okay, yeah, but listen to me. An array is not an L. It's either a rectangle or square, no L's. So 1 times 12 is 12. That's right. So what would be the related multiplication fact to 1 times 12? Okay, so that one you need to write down. But I need you to erase 7 times 6 because that's 42, not 12.
Oh.
Okay? An array, this is a helpful hint. An array is always either a rectangle or a square.
What about do we have to erase this one?
Yep, because 6 times 7 is also 42.
It's the opposite. That's 6. There we go. I don't see it. Oh, 2. Yeah, we just need to come up with one more and then do the opposite. I think we can do this. Like all up. So that's going to be a long rectangle, right? And then you go 7 times 1 times 6 is 6.
No, it's 12.
6.
And then 2 times 6 is 12.
2 equals 12. 6 by 6. We already have 6 times 2.
No, we have to do 3 times 4.
Oh, good.
We can do this one backwards 6 times 2.
4 times 3.
We can do 12 times 1 backwards.
Yes, 4 times 3.
4 times 3.
No, 12 times 1.
Okay.
Oh,
No, that's
oh, we can't do 3 times 4.
4.
Or did you already do that? But
Reverse.
I'm going to give you guys about 3 more minutes. Yeah, 3 more minutes.
I've got one. I think it's this one. 4 more. So I'm done. One more.
Be a rectangle or a square. But you're missing one. Maybe a related fact to one you already have.
You want something?
All right, about 30 more seconds. Is it 12? No, it has to be a rectangle or a square.
That's how an area is.
Okay, area. The product
of length times width.
area. Okay, so a couple things I should have told you that an array has to be either a rectangle or a square. It cannot be just an L. Okay? Has to be a rectangle or a square. Just like all of our cards are either rectangles or squares, right? Were there any L's on our cards, Valentine? Did you see L's over there when we were sitting at the carpet? No. So, I'm sorry, that's my fault. So, no L's. So, who can share some dimensions that they came up with? Lillian, give me one.
2 times 6 equals 12.
Raise your hand if you had that one. Okay, hands down. Oh, so you had the related one, 6 times 2. Okay, so 2 times 6 equals 12, 6 times 2 equals 12. Who has something different? Tegan, what did you guys have?
12 times 1 equals 12.
Okay, 12 times 1 equals 12. And Aiden, what's the related? 1 times 12 equals 12. So, how many, how is that impossible?
Because I thought we would have to do it on a 100 grade. And then that's what more. So I thought it would
Oh.
another.
Another misconception.
Yeah, I thought it wouldn't be possible because I was like,
Gotcha. Okay, so you were thinking because we were building them on here that there weren't 12 down this way, so you couldn't do it? Interesting. All right. Actually, when we're building with tiles, we can do, it doesn't have to stay within this. But that is a good thought there. I would have never thought that. Okay, so how many did we come up with total?
6. I got 2 stuff.
How many did we have total? We came up with 2 together.
Plus 2 more equals 6. That would be 6.
Okay, so we have 3 times 4 equals 12, 4 times 3 equals 12, 2 times 6 equals 12, 6 times 2 equals 12, 1 times 12 equals 12, and 12 times 1 equals 12. So we should have 6, right? So there are 6 arrays with a product or area of 12. So, what conclusions can we make about area now that we know that there are 6 that can be the area of 12? What conclusions can we make about area? So think about this. If you have 12 as an area, the area will be 12 for all of these, right? But will they all look the same?
No.
No, so their dimensions can change, but the area will stay
Stay the
the same. So we're using these facts that we came up with. All of their areas are 12, but the dimensions change, right? Does anybody know any more numbers? Okay, here, I need you guys to listen really quickly. I need markers closing down, I need tiles down, I need hands in your lap or folded on the table. Aaron, can you turn your body so you are focused on what I'm saying? I really want you to hear this question, okay? Can anybody come up with a different number that is a product and and has multiple factors or multiple dimensions. So we just talked about 12, and 12 has 6. Can anybody else come up with a different number that has multiple factors or multiple dimensions? Troy.
14.
Okay. Can you give me an example?
7 times 7. 7 times 2 equals 14, and 2 times 7 equals 4.
Okay. That's 2. And then, of course, we would have 14 times 1 equals 14, and 1 times 4. So that would be 4. Are there any numbers that have more than 4 that you can think of? Lillian?
18.
18. Okay, can you give me some examples? You're right.
6.
That's a good one.
Yeah.
Go ahead.
Trying to think. 6 times 3.
Yes. 6 times 3. And what would be the opposite of that?
3 times 6.
Uh-huh. And what else?
18 times 1 or 1 times 18.
And there's one more. Aiden?
26.
Nope, we're still talking about 18. You know?
8 times
8 times 2? No. 8 times 2 is 16.
2.
You're close. You're on the right track. Joey?
9 times 2.
9 times 2. So we got 9 times 2, 2 times 9, 18 times 1, 1 times 18, 3 times 6, 6 times 3. So there's 6 of them, just like 12. Can anybody else think of maybe one more? Think about when we were playing loops and groups. Tegan? 10? Okay. 10 has a couple. Callan?
I was thinking 24 for 1.
Yes, you're right. Both of those, yes. 24 especially. 24 has quite a few. Good. Okay. I want you to turn and talk to your partner. Okay, but here, this is what I want you to talk about. Okay? I want you to talk about in what kinds of situation would we need to use multiplication. So think about like your everyday life. Or think about things that we do in the classroom. What kind of situation would we need to use multiplication? Go ahead and turn and talk to your table group, or your partner. Why would we need to use multiplication?
and then you have to add
Long box.
I know. Yep. Okay. Lance, look at me. Who would like to share? Tegan?
Like a treasure, it would have, so if like it was having a fundraiser and it would be to count, divide, subtract, or multiply, or add how much money it would have for the school.
Okay. So she's talking about a treasurer. Are you know what that is?
No.
Okay, it's somebody who's in charge of money. So like our PTA has a treasurer, and they count the money that we get. So yes, you're saying multiply would make it easier for them to count the money. Yes. Callan?
Whenever we have football, we need a multiply.
Oh, okay.
Field goals.
Okay. So each time there's a touchdown, it's how many points?
6.
6. So you're saying multiply by 6. So if you have 10 touchdowns and you multiply by 6, what would that be?
36.
Wait, what? 6 times 10?
Oh no.
60.
There we go. Okay, McKenna, last one.
Like if you were going grocery shopping and this was a certain amount and that was a certain amount, like it was $10.99 and $3.99, that would be, so 99 is basically like 100 cents. So also tax, so you pay for that and pay for that, and it'd be around $30.
So you're talking about like buying multiple things at the same price?
Yeah.
Okay.
It's like,
Yeah. Okay. One more question for you to talk about with your partner. One more question. Why would we choose to multiply instead of adding? Go ahead. I'm going to give you 1 minute. Why would we multiply instead of adding?
and then you would just have to it costs if you want to
Okay, Leanne. Okay, who wants to share? Why would we multiply instead of adding? Akila.
because you can like see you'll have to do all those numbers and then you won't get it right.
Okay, are you saying that it's faster? Okay, to count, you're talking about counting by 5s to multiply by 5. Okay, Lillian.
So it's quicker to add with it because if you're on a harder question to add, you don't want to use your fingers, you can do the multiplication. It's probably easier to do multiplication when it's hard questions.
All right. Yeah.
Like adding, it just constantly keeps on going, and in multiplication you can only just like adding, it just keeps on constantly keeps on going, and where multiplication it just like it's like takes shorter time. So like 3 times 3 you already know this, but like and then to do it, so you just like basically it's with 3 items in it.
Okay. Okay. So I'm hearing you guys say that multiplication is quicker than addition. I would have to agree with you. Yes. It's quicker. It comes quicker to your brain. Okay. So today we talked about the area model or using arrays for multiplication. And we talked about dimensions or factors. We are going to continue working with this, and we're also going to use a strategy with arrays on figuring out the quotient, which is actually the answer in a division problem. So we're going to use arrays for multiplication, and we're going to use arrays for division. We will be learning that too. Okay? Division. Okay, so this is what I need for you guys to do. I need for you to make sure your tiles are back in your cups. I need you to erase your whiteboards